Howdy, AP PreCal. I'm finishing up the little bit we're going to do on series here. You were supposed to watch this cartoon, so look for that and go watch it because it's really worth it. Okay, so the question is it possible to take the sum of an infinite series and get a finite number? Yes, if the series converges. So they talked in the video about what it means for a series to converge and diverge. Diverge means the values keep getting bigger and bigger and bigger, either in the positive direction or the negative direction, and you can't find an infinite sum because, like, if you think about, like, okay, what's 2 plus 4 plus 8 plus 16 plus 32? If you stop here, you can find a sum, but as soon as you think you've got an infinite sum, I'm going to add the next term after where you stopped and I win. Okay, so this series, this one diverges. Oh, I knew the bell was going to ring. Okay, we'll see if anyone comes in to see me. But the formula for an infinite geometric series is a sub 1 over 1 minus r, given that the absolute value of r is less than 1. So if your r value is getting smaller and smaller and smaller, your infinite geometric series will converge to a particular value. And you can find that value using this formula. In PreCal, this is the only converging series that we discuss. BC Calculus has a whole bunch of tests to figure out if your series converges or diverges. This is one of the things. So this is why we're doing this. We're introducing the idea and giving you kind of a leg up. Okay, prove that 0.9 repeating is equal to 1. I love this one, and I argue with kids every year. Okay, one way to do this is to say, well, this is 0.9 plus 0.09 plus 0.009 plus, well, and so forth. Okay, this is a geometric series where the first term is 0.9, and my common ratio, well, we were multiplying it by 0.1. Okay, so I just said that the sum would be equal to the first term over 1 minus the common ratio. Well, this gives me 0.9 divided by 0.9. Well, 0.9 divided by 0.9 is 1. Oh, I forgot in my answer key, there was another way to do this. There's 2 more proofs. I wrote one of them down on my answer key, but the other one came to me. We can say, here's proof 2. We can say let x equal 0.9 repeating. Okay, then 10x would equal 9.9 repeating. Well, what happens when I do 10x minus x? That would be 9.9 repeating minus 0.9 repeating. What's going to happen to all my decimals? They're gone. And I get 9x is equal to 9. And what does that give me? 1. Divide both sides by 9. Proof number 3, I'm on a roll. What does 1/3 equal? Well, 1/3 equals 0.3 repeating. What happens when I multiply both sides by 3? I get 1 is equal to 0.9 repeating. Yay! I think those are fun, but every year I have somebody argue with me. Okay, convert this to a fraction. We can do it, I like to do it this way right here, but you can also use this method in a similar fashion. So, well, I'll show you both. This is 0.617, that's my birthday, plus 0.000617, plus and so forth. So our first term is 0.617. Our r value is 0.001. And so this becomes, our sum is 0.617 over 1 minus 0.001, which gives me a 0.617 over a 0.999, which is 617 over 999. I don't feel like doing it the other way. Okay, find the value if it exists. Well, first of all, quadratic, no, it diverges. These values get bigger and bigger and bigger, and you keep adding the sum of bigger things, and it gets bigger and bigger and bigger. This one is an arithmetic. Arithmetic will diverge. Okay. This is geometric, and its common ratio, its r value is 1/2, which is less than 1. So we can say my first term, a sub 1 over 1 minus r, so 10 divided by 1/2 is equal to 20. We can say on this one, yes, my first term, plug in 1, my first term is 1/2. 1/2. My common ratio is, oh no, this r value is bigger than 1. No good. This diverges. This one you think, oh, look, here's the same idea, but no, this one's tricky. Did you catch it? What happens when I have 3 to the negative n? This would be equal to the sum as n goes from 1 to infinity of 90 times 1/3 to the positive n. Ooh, The first term when you plug in 1 is 30. So this is 30 divided by 1 minus 1/3. This is 30 times, well, divided by 2/3 means multiplied by 3/2. So 90 over 2 is 45. And the last one, I don't know why I'm going in a weird order. There you go. The very first term we want is we plug in a 2, and we have 200 times 1/4. So 1/4 of 200 is 50. So 50 divided by 3/4 is going to be 50 times 4 over 3, which is equal to 200 over 3. Cool. Okay, write the first, this is the last one for the day, and it's time for me to go home. Write the first 4 terms of a sequence whose common ratio is, and whose infinite sum. Okay, so a sub 1 over 1 minus r. A sub 1 is this. Okay, so what do we have? We have 81 over 14 is equal to a sub 1 over 14 ninths. So if I multiply both sides by 14 over 9, then all that will cancel, and that cancels, and I get 9 is equal to a sub 1. So now I need, okay, so my first term is 9, and then I'm going to multiply this by a negative 9 over, that's a 5 over 9, right? Okay. So 9, negative 5, 25 over 9, and a negative 125 over 81. All right, good luck. Go practice.